Now let's have sampling techniques. To recall, statistical data are usually obtained by counting or measuring items. Primary data are gathered data directly from the source, and secondary data are data gathered from written or published works. Sampling methods. So we have the probability sampling and the non-probability sampling. For probability sampling, every unit of the population has an equal chance to be selected. While for non-probability sampling, not every unit of the population has an equal chance to be selected. It involves non-random selection based on convenience or other criteria. So how to find the number of samples to be taken from the population? So to determine the number of samples to be taken from the population, we use the Sloven's formula. So the Sloven's formula is that the number of samples is equal to the population size over 1 plus the product of the population size and the square of the margin of error. Now, the margin of error is determined by the researcher. So, in research works, researcher determines the margin of error that is appropriate to his or her research work. Now, in most cases, the margin of error used in most researches is 5% or 0.05. However, this is not fixed because, as I said a while ago, researchers will determine the appropriate margin of error for their own research works. But in most cases, 0.05 is used as a margin of error for most of the researches that is conducted so far. Alright? Now, let's have an example. Suppose the target population for a research are the college students of a university. For the current school year, there are 1,100 students enrolled as shown in the table. So we have here different departments. And let's find the number of samples to be taken from each department using 5% margin of error. So for education, we have 90 students. Accountancy, we have 110. Engineering, we have 490. And information technology, we have 410. So when you total all these number of students for each department, it will give us 1,100 students. So what we are asked is to find the number of samples to be taken from each department. But before that, we should first identify the number of samples to be taken from the entire population. So using the Sloven's formula, okay, let's identify our given first. Okay, we have here 1,100. So that is our population. That is our capital letter N. And we have 5% margin of error. So our margin of error is 0.05, is the decimal expression of 5%. Okay, now solving for the number of samples using the Sloven's formula, we have N is equal to, okay, big letter N over 1 plus big letter N times E squared. Plug in our values, so we have 1,100 over 1 plus 1,100 times 0.05 squared. Okay? Alright. Now, using your calculators, we'll have Okay, 293.3, no? And it's a non-terminating decimal, so we'll have 3 bar there. Now, since we are talking about number of samples and we can't get a person that is 0.3 in value, so meaning to say, when we find for the number of samples out of the population using the Sloven's formula, we'll always have to round up. Okay, so our number of samples to be taken from the population of 1,100 is 294. Sorry, 294. Okay, so this will be the number of samples that we should get from the population, which is equal to 1,100. Now, we have here number of students for each department, and our task is to find the number of samples from each department. And we know that we should get a total of 294 as a total number of samples. Okay, when we add the number of samples that we get from each department. So how are we going to do that? Okay, so by, of course, simple application of percentage, we'll get what we are asked for. So here we have, for education, we have 90 students, right? Now, to get the number of samples from each department, divide 90 by the population, which is 1,100. So we have 90 divided by 1,100. Okay, it will give us approximately equal to 0.08. I hope you have your calculators with you right now, so you can go with the discussion. So you have 0.0, approximately equal to 0.08. And we will multiply that to our expected number of samples, which is 294. So again, repeat the process. 90 divided by 1,100 times 294. So it will give us approximately equal to 24.0545 bar. So we have number of samples for education, we have 24. Okay, so out of the 90 students from the education department, we'll have to get 24. Next, we'll follow the same process for 110. So we have 110 divided by 1,100 times 294. And it gives us 29.4. So we will only need 29 students for accountancy. Next, we'll have the engineering department. So we have 490 divided by 1,100 times 294. It gives us 130.96. We round it up. We round it off. We have 131. So for engineering, we need 131 students or representatives. Next, we have 410. So it's the same process. 410 divided by 1,100 times 294. And it gives us 109.58. Round off, so we have 110 for the IT. Now let's try to check if we're going to add all our number of samples from each department. Will it sum up to 294? Let's try. 24 plus 29 plus 131 plus 110. It gives us 294. So the breakdown of the 294 samples from each department are as follows. For education, out of the 90 students, we'll have to get 24 students as representatives for the education department. Accountancy, we have 29. Engineering, we have 131. And for the information technology, we have 110. Okay? So, next. Let's have the probability sampling methods. So first, we have the simple random sampling. So each sample of the same size has an equal chance of being selected. So examples of simple random sampling is the lottery method, wherein we get to write, for example, we get to write the names of the entire population in piece of papers and roll it, and then randomly pick from it. So that's the lottery method. And the other is a table of random numbers. Now, simple random sampling is used to make a statistical inference about a population. It helps ensure high internal validity of the data that we will be gathering from these respondent from the sample. Now, simple random sampling works best if you have a lot of time and resources to conduct the study. So if you are studying a limited population that can easily be sampled. Okay? Now let's have the systematic sampling. So for this sampling method, we randomly select the starting point and take every kth piece of data from a listing of the population. So to find k, we use the formula k is equal to the population size over the sample size, wherein we know already how to find the sample size. That's through the use of the Slovitz formula. Okay? Now, in systematic sampling, you have to make sure that your population numbers are arranged in order that's according to your research or study. So some may have it if the respondents are, if important variable of the study is about age, then the ages of the members of the population should also be arranged accordingly. May it be increasing or decreasing. So this arrangement gives a fairly representative sample, as it will include participants from both the bottom and top ends of the population. Okay, so that the participants or the samples that you will be getting can represent all the entire spectrum of the ages. Okay, so after that, after you arrange your data according to age, then we need to calculate, or we need to find specific data to be included as sample using this formula already. So, for example, if your population is 1,000, now let's have our example a while ago, 1,100 divided by the number of samples, which is 294. So we'll get 3.7, so that's approximately equal to 4. So every fourth member of the listing will be part of the sample. That's how to apply systematic sampling, hopefully when you do research. So again, how is systematic sampling different from simple random sampling? So in simple random sampling, as we described it a while ago, every member of the population has an equal chance of being selected. But because it is simple random sampling, let's go back to our age example a while ago. If we do simple random sampling and our important variable in our study is about ages, then there is a possibility that not all ages are fairly represented by the samples that can be chosen. Whereas in systematic sampling, because we do ordering, we do listing, and the list is ordered, may it be in increasing or decreasing order, we are sure that at the very least, all of the ages in the age spectrum are fairly represented in the sample. And this makes our data more valid. Next, the third method is stratified random sampling. So in stratified random sampling, we divide the population into groups called strata, and the samples are randomly selected from each stratum based on specific characteristics. Example, race, gender, location. Okay? So every member of the population should be in exactly one spectrum. So when we do stratified random sampling, we should take note that every member should be in exactly one stratum. Now, each stratum is then sampled using another probability sampling method, such as the cluster or simple random sampling, allowing researchers to estimate statistical measures for each subpopulation. And then researchers rely on stratified random sampling when a population's characteristics are diverse and they want to ensure that every characteristic is properly represented in the sample. So here we have the steps in stratified random sampling. Population, and then we group the population according to identified stratum or strata. And then by random selection, we can apply here simple random sampling. We get to identify our samples. Okay, so that is stratified random sampling. Next, we have the fourth one, that's the cluster or area sampling. So in cluster or area sampling, we divide the population into clusters and then randomly select some of the clusters as sample. So in cluster sampling, okay, it is a method of probability sampling that is often used to study large population, particularly those that are widely geographically dispersed. Researchers usually use pre-existing units such as schools or cities as their clusters. So, how to do cluster sampling? The simplest form of cluster sampling is the single-stage cluster sampling. So it involves 4 key steps. Step 1, of course, just like any other sampling methods, we need to define the population. So step 1 is defining the population. Step 2, divide the population now into clusters. So here we have different clusters of population, but we have to make sure that each cluster's population should be as diverse as possible. Next, Each cluster should have a similar distribution of characteristics as the distribution of the whole as a population. And third, taken together, the clusters should cover the entire population. Okay? After we have identified clusters of our population, we randomly select clusters to use as sample. So in this, clusters that are colored in yellow are the selected clusters via random sampling, of course, as samples to research. And lastly, step 4 is the collection of data from the sample already. So I hope it's clear, especially the distinction between stratified random sampling and the cluster sampling. Okay? So next, if we have probability sampling methods, then we also have non-probability sampling methods. Okay, and these are the most commonly used non-probability sampling methods. First, we have the quota sampling, in which sample is selected according to quota system. Next, we have the purposive sampling, in which the researcher chooses the sample based on who they think would be appropriate for the study. And third, we have the convenience sampling. And this involves choosing respondents convenient to the researcher, also known as the accidental or opportunity sampling. Okay? So again, as I recall, we have probability sampling methods and non-probability sampling methods. For probability sampling methods, we have the simple random sampling, systematic random sampling, stratified random sampling, and the cluster or area sampling. And for non-probability sampling methods, we have the quota, purposive, and convenience sampling. So I hope you get to distinguish the differences among those sampling methods and proceed to your activity.